Okay. So let's bring this back. And by bring it back, I mean shove it somewhere else. So I think we want send video frame to still be roughly the same. Let's take a look at our state. So I think our video output should probably have the queue. I think that makes sense. Yeah, our video output should definitely have the queue. What are we actually sending? Is it a video buffer? Yeah, we're sending a video buffer. Well, our video buffers are going to be homogeneous or homogeneous. Where else do we use video buffers? Because we might even get rid of that. That might not be a useful abstraction. The thing I want to avoid is I want to avoid another copy. I would like to just write directly into the queue. And I might need to have a mutex for writing, unfortunately. Let's start writing some code. So here we're going to have, do we have a video buffer already? We don't. So we're going to have unsigned int width, unsigned int height, unsigned int depth, and then we're going to have this is going to be a semaphore. So let's go on unsigned chart buff, and what I want is I also want to know size t capacity, I think. Because I think I want to cram all of the frames into the one buffer. If I do it as a ring buffer, is that how I want to do this? Because when I'm writing to the buffer, what I want to do is I want to write from end and then bump end. As long as the number is less than cap, no cap. Only one thread is going to be writing. This is good for Bitcoin, as they say. I think a semaphore should be what we want. What is the actual thing? Like Sam and net? Here we go. A non-zero value for p shared specifies a shared semaphore that can be used by multiple processes, which this implementation is not capable of. Okay. I'm confused. You're saying multiple processes. Oh, as in like shared memory? Okay, yeah, that's fine. I don't need that. So if we go man sem weight, yeah, I think this is good. Does the sem init give a max value? To have the value, it does not. Yeah, I think what I can do is I can have the target number. Do you get the number when you have sem weight? Returns the value 0. No, it doesn't. Oh, I'd really like to know what the number is, unfortunately. That is unfortunate. I don't think there's a good way to do that otherwise. I may have to use a mutex, which is dumb. I may have to use a mutex with a number. C11 atomics. I could be able to get away with an atomic, but I'm somewhat skeptical. Atomic fetch add. So we can do an atomic exchange, I guess. Okay. So if we can do an atomic, whoops. What happened? Oh, I see. Go over there. If we can do an atomic compare and exchange. No, we can't do an atomic compare and exchange. Oh, this is so dumb. We're going to have a mutex and a value. That is so silly. Yeah, and so the number will need to be an atomic. Can we do a fetch and decrement? That's a possibility, right? Fetch sub. We might be able to avoid a mutex, because we can fetch the value and sub 1 from it. We'll try with the atomic. We'll see what happens. So what we're going to have is atomic tickets, or maybe just num. Maybe just num. This should be a SST. I don't think cap needs to be atomic. That's a very good question. If we want to grow it, it does, but I don't think we do. I think this is const even. No, that doesn't make sense. Okay, so this is the number that we have. And then what's going to happen is when you... No, this is the number of free spots. So I guess this is tickets. That'll do. So tickets starts at cap. And then you're going to fetch sub. And then what you're waiting for... If you've got the first ticket... No, this doesn't work. Does it? Okay, maybe I need to... So if we have n threads... Right, where thread 0... and we have a cap of let's say 5. We'll see what happens. So if we take ticket 5, then cap goes to 4. No, tickets go to 4. So we're waiting. This is really hard to do in text. I would want to draw this out with pen and paper, but you can't all see that, unfortunately. So what we're waiting for, when we take a ticket, want to return first. So we want to return first, which cap minus ticket, which equals 0. So if cap is 0 or more, we can give it back. So we want to return second. Cap minus ticket equals 1. But it's not true. Because what happens if 4, so if 3 takes a ticket, so our target is 2, right? And then here our target is 1, and then here our target is 0. Right, so what happens if here 4 finishes, but 5 is still going? So after 3 has taken a ticket, there are still 3 tickets left. And so 4 looks at that and goes, okay, so 4 looks at that and goes, hang on, I can only return when there's there are 4 tickets. Yeah, okay, no, I think we can trivially order this. So what I was worried about just then is that, okay, 5 finishes first, right? Then they take another ticket immediately. No, 5 finishes first, and then 4 finishes, and then 5... Maybe this is fine either way. So 5 finishes. Can it take another ticket immediately? I don't see why not. Yeah, so then 5 takes another ticket and finishes again. I think there's a much easier way to do this. The easier way to do this is the first thread can only take a ticket when there are 5 tickets left. I think that orders this. And then the first thread can only take a ticket when there are 4 tickets left. I think this orders this rather trivially. Okay, I think we can work with this. So the 0 thread will only take a ticket when there's, or thread I will only take a ticket when there are cap minus I tickets remaining. That's the only time they're allowed to take a ticket.